Welcome to my presentation. This presentation is going to focus on cross-curricular issues within mathematics and science. We will look at cross-curricular definitions, the links between maths and science, advantages and disadvantages of using a cross-curricular approach, and finally the use of ICT to support learning in the classroom. The first question we need to consider is what cross-curricular actually means. Hayes 2010 explains that most definitions of cross-curricular work are also known as curriculum integration, which emphasises how combinations of subjects are used within project or thematic work. This means that it incorporates more than a single subject area, for example, mathematics and science. Kelly and Steed 2013 stated that a cross-curricular approach in the primary curriculum have been the subject of debate for some considerable time, and have tended to be characterised as a debate about the merits of progressive or child-centred forms of teaching as compared to traditional teaching in which subjects are taught discretely. As has already been suggested, cross-curricular work has been associated with more child-centred constructivist approaches to primary education, which in the last century was endorsed by the Haddo Report of 1931 and the Plowden Report of 1967. The Haddo Report argued for the reconsideration of discrete subject teaching and suggested that the curriculum be thought of in terms of projects or topics instead of individual subjects. Although the Haddo Report was known as a progressive, constructivist approach in the UK, it was not fully advanced until the Plowden Report was introduced. This report suggested that discrete teaching is artificial and is better to have different subjects which are linked together, for example, mathematics and science. Although discrete subject teaching became more broadly accepted in primary schools, a 10-year study by Boyle and Bragg 2008 between 1997 and 2007 showed that subjects continued to be taught in a cross-curricular way at least for some of the time throughout this period. The study found that from 2002 schools began to reintroduce cross-curricular teaching, often for the pragmatic reason that it enabled them to meet the expectation in the national curriculum that all children are entitled to a coherent, broad and balanced curriculum. Hayes 2010 once questioned, what is it that makes cross-curricular work a successful approach for teaching and learning? As has already been suggested, cross-curricular teaching and learning has strong links with a constructivist view of learning, as children work collaboratively and learn from their own direct experience. One of the features of a constructivist view of learning, based on the work of both Bruner and Vygotsky, is that learning is a collaborative process both between children and between children and their teacher. There are many advantages to cross-curricular teaching, which is supported by the work of Rose 2009, who stated that children would have a better understanding of the world. Rose also mentioned that it allows more opportunities for creativity and application in the classroom. Following on from this, Claxton 2002 suggested that a cross-curricular approach will develop skills to support future careers. Driscoll et al. 2011 also explains that children would have more involvement in their learning. And finally, Hiscock 2012 mentioned that embedding math skills, particularly in other subjects, makes a real difference to children's understanding and enthusiasm to the subject. When discussing a cross-curricular approach to teaching and learning, it is important to keep in mind the concerns that have been raised by critics of this approach. These are that it lacks rigour and pupils may not develop essential subject-specific skills. Subjects also may lose their identity if they are not seen discretely. Another concern that critics see is that cross-curricular learning is superficial and fragmentary. If poor links are made, this would result in little progress. Next, the presentation is going to look at the links between mathematics and science. A question that needs to be considered is why should mathematics, a subject that primary practitioners see as discrete, be combined with any other subject, one being science? The Department of Education states that mathematics is essential to everyday life and critical to science, and that children should apply their mathematical knowledge to their understanding of science. This included collecting and presenting data, for example, in a bar chart. Hiscock 2012 suggested that science can provide a good opportunity to practice various mathematical skills. Hiscock also goes on to link interpreting and presenting data. She explains how children can complete the process of constructing a bar chart or line graph, but lack the understanding to interpret what it shows. However, if the children are involved in collecting the data during a science experiment, this would help them to interpret the data overall. Another link Hiscock explains is how measurement is connected between mathematics and science. Measuring skills can be taught in one of three ways. 1. Abstractly, where the measuring equipment is used but with no context. 2. In a maths context, where there is a purpose to the task. And finally, 3. In a science context, where some additional knowledge or understanding will be gained. Kelly and Steed, 2013, also goes on to explain that for younger children, numbers enable them to talk about their science and explain their findings. So the beginnings of early counting are intrinsic to their understanding of the world, which they engage with as scientists. This shows how the two subjects can be linked together, as it shows that number is an important feature of science, which enables children to connect with the subject. The National Curriculum 2014 also shows links between mathematics and science. For mathematics, it shows that pupils should be taught to interpret and construct simple pictograms, tally charts, block diagrams, and tables, ask and answer simple questions by counting the number of objects in each category and sorting the categories by quantity, and ask and answer questions about totaling and comparing categorical data. Science is very similar, as it shows record findings using simple scientific language, drawings, label diagrams, key, bar charts, and tables, ask relevant questions and use different types of scientific inquiry to answer them, and gather, record, classify, and present data in a variety of ways to help answer them. Here you can see the clear links made between both subjects, for example, the link between recording data in charts and various types of tables. An example of using mathematics to support science or understanding of the world in a primary classroom was during my first teaching practice. I taught a lesson exploring ice to a reception class. There were 4 different activities around the classroom for children to access, focused on the topic of ice. The focus of the lesson was for children to read the thermometer using the correct scientific terminology, and were then asked what happens to the thermometer when the ice melts. Children were asked how many degrees it had dropped by. Cubes were used to show the starting temperature, and then the children had to take them away once the ice was melting. Another component that was measured was time. The children had to time how long it took the ice to melt. They loved this experiment as it was very practical, and they were all on task and motivated throughout. The next thing that will be focused on in this presentation is the use of ICT. There is various research which has been undertook over the years to suggest that the use of ICT increases motivation between children and the focus within lessons is enhanced overall. To support this, Scuttle 2014 explains that ICT is one of the driving elements of the current primary education and often replaces commonly used teaching methods. Justin and Peacock 2012 also suggests that the use of ICT encourages children to take ownership of their learning and can also develop maths and science in terms of how data is collected and presented, for example, data loggers. Hiscock 2012 supports this by explaining how data loggers are vital for helping children to investigate how things change over time. This then leads to the link between ICT and the 2 other subjects mentioned in this presentation, mathematics and science. Meadow 2012 explained that using ICT in science makes it more exciting for the children and leads to improved attitudes to science learning overall. Similar can be said between the links of mathematics and ICT. Jarrett, 1998, suggests that ICT-based tools provide pupils with an advanced communication capability, allowing them to use graphics, images, and text together to demonstrate their understanding of mathematical concepts. To conclude, we should discuss if maths and science should be taught in a cross-curricular approach or as discrete subjects. Although there are advantages and disadvantages of teaching in a cross-curricular way, I believe that cross-curricular teaching is highly beneficial as the pros outweigh the cons in general, as both maths and science link more naturally together than other subjects. This is supported by the work of Rose 2009, Hiscock 2012, Hayes 2010, Claxton 2002, and finally Kelly and Steed 2013, who are all in favour of cross-curricular teaching. The new national curriculum makes direct links between maths and science to support this. From all the evidence gathered, it shows a clear advantage of cross-curricular teaching, as I have found that it allows children to learn more easily and enables them to use knowledge that they have acquired in a number of different ways. Another key point that needs to be considered is that cross-curricular teaching is not about weakening and fading away subjects in any way. Rather, it is about the development of an enhanced pedagogy that a skillful teacher adopts for the explicit purpose of enhancing teaching and learning within the primary classroom.